We have a new project at the Institute called 12 Labours, funded by MB, and it's about looking at the 12 organ systems of the body, hence 12 Labours, and using our computational methods that we've developed over many years for understanding the link between cells, tissues and organs and the whole integrated function of the body. 12 Labours is very much about that holistic view of the body, but using quantitative frameworks to understand measurements that can help you inform about diagnostics and treatment strategies for various diseases.
So the vision is to create a personalised digital copy of each patient, known as a digital twin. So medical professionals will be able to perform controlled and repeatable tests on these digital twins to find out which treatment may work the best and also identify any serious health issues. Our research group is working on pulmonary hypertension, which is a condition that affects millions worldwide. We're looking at how digital twins can help with diagnosis, treatment, management and monitoring, and see how patient-specific responses might be varied within this.
So a major challenge for implementing these digital twins or personal healthcare models across different organ systems are that they are derived from different types of images, and these can include magnetic resonance imaging, MRI, CT scans, or ultrasound. So in my work, I will be implementing new MRI capabilities in New Zealand, and these will provide new physiological information of the heart and lungs, all without the use of ionizing radiation. This will then be used to create new, better personalised healthcare models to explore the interaction between the heart and lungs in diseases such as pulmonary hypertension.
We're developing a tiny implantable pressure sensor. It's small enough to be implanted within the brain or the pulmonary artery near the heart. We power it wirelessly with this wand. It powers the implant, we take a pressure measurement, and that gets transmitted back to the wand and it's uploaded to the cloud. This is really helpful for people who live remotely or far from the hospital because they can measure their pressure from home and a doctor can view that online. This is especially important for people with a condition called hydrocephalus, where they produce too much fluid within their brain and the pressure increases, so we can monitor that from home, or for people with heart conditions where we could monitor their pulmonary artery pressure remotely.
Conditions such as endometriosis and preterm labour have a huge impact on the health and well-being in our community. We're using a combination of mathematical modelling and experimental approaches to investigate what goes wrong in these conditions to help inform clinical application in the future.
So endometriosis is a chronic condition where cells like those that line the uterus grow in other areas of the body. We really don't understand a lot about this disease. This is in part because diagnosis usually occurs several years after the disease has onset. So we're developing a mathematical model to help better understand the condition and also to help pinpoint potential therapeutic targets for future research.
We've developed this camera-based 3D imaging system for linking digital twins to their real-life human counterparts. By accurately measuring the human body, we can estimate the position and orientation of organs within their digital twin. This allows us to develop personalised healthcare models for every individual.
Upper and lower limb movement disorders associated with cerebral palsy, stroke, and others are becoming more and more common. They are debilitating for the person affected and very costly in terms of treatment, assessment, and physiotherapy. Current treatments are a sort of one-size-fits-all, which doesn't work for every patient. By using wearable sensors or motion capture technology with computer models, we can personalize treatment and diagnosis and help clinicians to make better decisions about treatment plans, leading to better outcomes for the patient.
Diagnosis of disease is often far too late because patients have to self-report their symptoms to their doctor or carer. If we could predict disease early, using digital twins and computational models combined with implantable devices and wearable sensors, then we can allow doctors in a remote circumstance to be able to find disease early, take proactive response, minor modifications to prevent large-scale disease in patients.